Hi, so I'm going to be walking through question 8 of round 1 of the Maths Teams Olympiad competition. This question is quite nice. It gives you the knowledge needed to solve it. So with this information, I'm pretty sure most teams can solve this, at least the first part of the problem. So we've got that. We want A over B plus B over C plus C over A to be greater than or equal to 3. And it also happens there's 3 terms here. So it may be obvious, or it may not be, just to try the AMGM inequality on these 3 terms here. So let's do that. Well, we know A over B plus B over C plus C over A over 3 is all greater than or equal to the cube root of the product A over B times B over C times C over A. Multiplying through by this, we get that A over B plus B over C plus C over A is greater than or equal to 3 times the cube root of this, but look, the A's cancel, the B's cancel, the C's cancel, the cube root of 1. So this is just equal to the cube root of, this is just equal to 3. And there we go, we've done the first part. It's fairly straightforward. The second part is quite a bit harder, and you need to spot something to do it. So you may try, there's one thing I didn't add. We need to determine when equality holds. So equality holds when these 3 variables are equal. So when A over B is equal to B over C is equal to C over A. Well, that happens when A equals B equals C. There we go, that's the full solution for the first part. So now we need to find the minimum value of A squared over B plus B over C squared plus C over A. One may try straight away at the same method of AMGM, and this would give that this is greater than or equal to the cube root of A squared over B times B squared over C times C squared over A. This simplifies down to A over C. So we can see this minimum value of A over C isn't what we're looking for. We're looking for this to be an actual number instead of a term like this. So we need to manipulate the original expression, this thing here, in order to get an actual number to come out at the end. So let's try that. So we've got A squared over B plus B over C squared plus C over A. We want, when multiplying each of these terms like this, we want this to equal a number. At the moment, it doesn't fully cancel out, so we can play around with some of the numbers. If we play around with this term here, the C over A, and we can say this is the exact same thing as C over 2A plus C over 2A, and then if we multiply that by, well, if we write this like this, C squared plus A squared over B, so now we've got a new expression which is exactly equivalent to this. So you can use these two interchangeably, but it just happens when you multiply through by this one, well, let's just do AMGM on this, you get the following. So this is going to be the 4th root of, and then multiplying through, you see this, all the A's, B's and C's cancel, and you're just left with 1 over 4. So that's quite nice. The 4th root of 1 over 4 is equal to this term here, and we can multiply out by 4 again, and then get A squared over B plus B over C squared plus, we can recombine these now because it looks a bit nicer now, plus C over A is greater than or equal to the 4th root, 4 times the 4th root of 1 over 4, which is equivalent to 2 root 2. So the minimum of this expression here for positive real numbers is when equality holds, and that is when it's 2 root 2. So that's the solution done.